Hello, and welcome to D1 lessons expectations 5 and 6. Today we're going to be learning about types of data, types of charts, and types of distributions. And this is part of our unit on working with one variable data. So today we're learning how to choose a chart based on what kind of data is in front of you. And we're also going to learn how to look at that chart, examine it, and figure out, how is our data actually distributed? Is it all, evenly distributed? Are some data points occurring more frequently than others? And what could we learn from that? You're successful at these skills when you can identify different types of one variable data. So that's what we're learning, right? Different types of data. And then when you can represent that data with the appropriate graph. With the appropriate chart. And that doing that with and without technology is part of the expectations for you. You also know that you are successful when you can identify and describe the properties associated with very common distributions of data. So there are a few ways that data is distributed that you will notice will happen very frequently. Can you identify which one is which? To start off, let's get our minds in the right groove by, exploring the topic. I want you to take a look at these data types, and I want you to think about which category would it fit in. So the first category is actually called categorical data. So this type of data is data that can fit in one or more groups, but the groups have no order. So it's not like one group is better or worse than another. There wouldn't be, you could totally mix up the groups and the data would not actually change. When you have data that fits that, you call it categorical because it's just categories that you're splitting it up in. The other two types of data are both numerical, which means that your data needs to be sort of like numbers. Discrete data is data that can only be described with whole numbers. Data that has to be ordered, so it has to have like you should be able to put it from least to greatest in some way, but only whole numbers. Continuous data is ordered data that doesn't have to be a whole number, so your data can include decimals or fractions. Okay, well then without further ado, here is your first data type. So suppose you're collecting data and all the data gives you information about gender for each of the subjects. So maybe that person, the people who are responding to this survey or maybe this data, they might the data might indicate that this person is male, or that they are female, or that they are non-binary. Which of these three data types would you classify this data as? Right away, I can tell that this type of data, and hopefully you reach the same conclusion, this data is categorical. And the reason I know that is because the data types, the possible answers, are not numbers. They're actually categories. They're not, both of these data types, they need to be numbers. What about this one? Where would you classify this one? So if you're playing a role-playing game and you're trying to choose a character type, maybe some people pick warrior, some people pick mage, some people might pick to play a rogue. What type of data would that indicate? Well, that's also categorical. Easy to tell when the data type is not a number. Next, the roll of a six-sided dice. So the possible values that a six-sided dice can give you if you roll it are, it could give you a 1, a 2, a 3, a 4, a 5, or a 6. Those are the only options. What sort of data type do you think this would be? Take a second to think about that. A roll of a six-sided dice can actually be described, I think, in two different ways. It could either be discrete or categorical. I say categorical because, if these numbers are not actually, if one is not better than the other, if you're just trying to arrange them in any sort of way, then that would be categories. And the categories are, the different options. Yes, they are numbers, but if they don't have a specific order to them, then we would call it categorical. But if the numbers 1 to 6 actually mean something, if we're trying to get, a higher number is better, In that case, we would describe it as discrete data because it's true, the data is numerical, and yes, some of these numbers are bigger than others. So there's two different perspectives on this one itself. What about the number of players? When you play a game, sometimes the game goes up to 5 players maximum. Sometimes games are only for 1 player. Sometimes games can go to 10 or more players. What sort of data would this be? Well, I think we can know for sure that this is discrete, right? Because this is whole numbers only, because you cannot play with half a player. But more specifically, this is ordered data. 4 players is more than 1 player. In a different way than the roll of a 6-sided dice. Even though 4 is a higher number than 1, a 4 may not give you something better than a 1 might. So in this case, the 6-sided dice, it could be categorical, but this one will not. This one will only be discrete. Color choice, red, green, or blue. Which data type would this be? This would be an easy choice as well, categorical, because the data types are categories, not numbers. And there's no reason why green would be ahead of blue. It could even be behind blue, and red could be in any order as well. The amount of levels that a player has completed in some sort of game. Maybe this player has completed 1 level, maybe they've completed 7, maybe they've completed 19 levels. What sort of data type would you say this is? Categorical, discrete, or continuous? This would be discrete data, because although you could say, oh, I'm done 1.5 levels, that half level is not complete. You can only complete a whole number of levels. Discrete data is whole numbers only. You would only classify it as continuous data if the numbers could be decimals or fractions. Next up, a person's favorite type of game. So maybe they like to play war games, maybe they like to play deception games where they have to lie to people, maybe they like to play cooperative games. So you're collecting data on different people, and what is their favorite type of game? What sort of data would this be? This one's an easy choice. That would be categorical, right? Because there are no numerical values here. Next up, we have percentage completion. So maybe you're working your way through a book or a game or a movie, and you might say, oh, I'm 100% done the movie. I watched the whole thing. I'm 100% done the game. I did everything that there is to do in this game. Whereas other people, oh, they might just be 12.9% done that game. Some people might be 13.459% done the game. What sort of data type would this be? Because we can use decimals to describe how complete you are, how much you've completed, you would say that this is continuous data, not discrete data. You can use decimals to describe it. Next up, the number of cards in a deck. So you could have 52 cards, you could have 100 cards, you could have 60 cards in some decks. When you play games like, trading card games like Magic: The Gathering, sometimes you have 60 cards in your deck, sometimes you have 100. A standard deck of playing cards usually has 52. When you're looking for the number of cards in a deck, which sort of category, which sort of data would this fall in? Think about that for a second. That would be discrete data, because you can only describe them with whole numbers, and we can put these in order. 52 cards is less than 60. 60 cards is less than 100 for sure. And finally, what about the amount of time it might take you to do something? Maybe to the amount of time that you would need to watch a whole movie or read a whole book or run a whole lap around a track. Maybe that might take you 2 hours or 3.5 hours, or maybe even just 2 minutes. What sort of data would this be? This would be continuous data, for the very fact that you could have half of a unit, half an hour, even half a minute. You can divide that into decimals, and therefore this would be continuous data. All right, let's take a look at this data. And now if we can look at data and very easily classify it in one of these three, what do we do if we know what type of data we have? Well, to help us understand that data better, we would make a chart. But we have to pick the chart that best fits this data. A chart that would really help us actually understand the data. So if we had categorical data, like for example, if we were collecting gender information, and our respondents, our subjects, were saying that they were male or female or non-binary, what chart would display that sort of data best? Well, you have multiple options for each of these. And so one of the options, if you have categorical data, is a column chart. And a column chart looks like this, where there is an x-axis and a y-axis, and you just label all the different categories on the x-axis. So here you see male, female, and non-binary. And on the y-axis, you put, the count of how many of your responses fit that category. So here you can see that, in this data, there were about 50 responses that from the subjects that said that they were male. A little more than 50, about maybe I would say about 60 that said that they were female, and about 10 or 12 that said that they were non-binary. But keep in mind that because this is categorical data, this is not the correct order to put them in. In fact, there is no correct order with categorical data. The categorical data has no order. So it could even look like this, where female was first and male was next, and then non-binary, or in any other order. Non-binary could be in the middle or even first. It doesn't matter. With categorical data and with column charts, or some people call these bar graphs, but I think bar graphs are horizontal, and column charts are vertical. But in these sorts of graphs, the categories can be in any order down here. Okay? A column chart is used to compare the values across a few categories. So you wouldn't use this if there are like a lot of different categories. And you would use it when the order of the categories is not important. One more option that you might have is a circle graph or a pie chart. A pie chart is used to show proportions of a whole. So this slice represents 13 responses. This slice represents 51, and this slice represents 58. That is used to show proportions, and the entire circle represents the whole population. And we would use this to show that the numbers are always related to a larger sum. And if you add them all up, they should always equal 100%. Right here, I don't have percentages. I just have the total numbers that have responded to each. So 13 out of whatever the total is here. What about if we had discrete data? If we looked at data and we said, this is discrete data, I know that because it's whole numbers only, and we could put them into a certain order. What are some charts that would display that data best? You might say to yourself, I could use a T-chart or a table. And in this table, the way you would use this is you would say, okay, I have a number of players on the left side, and you would say 0, 1, 2, 3, 4, 5, 6, and so on for how many players. And then on the right side, you would put the frequency. In other words, how often did the people who answered your survey say that there was this number of players for the game? But this is not exactly a chart like the other charts are, right? Even though you might find out that, okay, none of the games have 0 players, 4 of the games have 1 player, 6 of the games have 2 players, 6 have 3 players, and so on. You might find out that most games have between 4 and 6 players, something like that. This is called a frequency table. And it's just a step in between getting all of your data and turning it into a chart. So this is a good medium step, and we'll see that happen for sure later on in this lesson. But the best chart that I would recommend is a column chart again. A column chart is also used to compare values across a few numerical ordered categories. Why wouldn't we use a pie chart for discrete data? The reason I wouldn't use a pie chart here is because a pie chart doesn't really have any order to the categories. There's no reason why, like, why is 13 here? It could be over here as well, right? We don't know where these slices have to be. They could be in any order. But with a bar graph or a column chart, notice the x-axis has all the numbers in order. And it's done that way for a reason, so that we can see that the highest bars are around over here. So you might say, so most games have a player count between 4 and 8. Not a lot of them go up to 9 and 10, although there are some that are only for 1 or 2 players. 3 players is quite rare, and it looks like most of them go from 4 to 8. Another reason why you might say a bar graph is better is because you're trying to actually compare values between each other, not compare it to the whole. If I didn't put the numbers 58 and 51 here, somebody might look at these and say, oh, those are basically the same. Whereas in a bar graph, you can see that female is clearly more than male. And over here, likewise, you would have a lot of slices, and some of them might look the same size. Whereas with a column chart or a bar graph, you would see that, so this one is slightly higher than this one. There's slightly more games that have 5 players than 6 players. Finally, continuous data. So remember, this is data that you're collecting from each subject, and each subject's answer needs to be a number. But that number can be a decimal, it can be a fraction, whatever. Which chart would best represent this? Think about that for just a minute here. So you might think to yourself, okay, the best option here would be something maybe like a column chart. Scatter plots and line graphs require us to have 2 variables, so we're going to knock those out. We only have 1 variable data. And a pie chart would be really hard to draw a slice for each different type of data. 12.9 would need a different slice than 12.8. How many people answered 12.9? How many people answered 12.8? That would be too many slices. And so for something like this, we would use something similar to a column chart, but we would just sort of group a bunch of columns together into sort of like a bucket. All the numbers from 1 to 5, for example, including 1.2, 1.3, 1.4, and we would create something that's called a histogram. This is an example of a histogram. Notice that it looks a lot like a column chart, but the x-axis, each bar, doesn't just represent one number or one category. Each bar represents a range of numbers. So this bar represents all the different numbers from 43 to 50. This bar represents all the different numbers from 50 to 57. This one from 57 to 64, and this one from 64 to 71. So a histogram is used to show the frequency of continuous numerical data or for large amounts of numerical data. So even though this data might be discrete, it might be only whole numbers, I would still use a histogram if there's so many of them that I would end up drawing like 100 different columns. I might just say, okay, let me just go to a histogram for that. Okay, so I only have to draw a few columns. You might say that this chart doesn't give you as much detail as a column chart would, right? How many people answered 59? I don't know, because this group shows all of them. It groups them all together with the ones who answered 57 and all the way to 64. So it doesn't tell me how many people answered just 58, whereas this tells me that, about 38 players responded, or 38 games have 5 players. How many games have 3 players? It looks like about 2 or 3. A histogram doesn't give you that much detail in it, but it does help us to still look at the data and learn things from it. When you're creating the groups for the histogram at the bottom, notice that there are some square brackets around here. And those square brackets mean that the number is included. So where would 50 go? The number 50. Would it go in this group or would it go in this group? It would go in this group because this one has a square bracket around the 50. This one has a round bracket around the 50. That means that all the numbers that are bigger than 50 would go here. Bigger than 50, but less than 57. So 50.1 would go here, but the number 50 itself would go here. The number 57, well, both of these have 57, but 57 would go in this group because that's that square bracket. 57.001, that's bigger than 57, so that would go in this column. So this group means all the numbers from 50 to 57, not including 50 because that has a round bracket. Okay, so we're done our minds-on activity now. We've looked at different types of data. We can look at a bunch of data if we have a data set and say, oh, is this categorical, is this discrete, is this continuous? And then we can choose the right chart to display that data. Let's see all of this in action. In this lesson, and you can use this QR code to go ahead and scan to, if you don't have 5 dice on hand, you could just scan this QR code to use Google to roll 5 dice. I'm going to ask you a couple of questions. I want you to really think about these answers. What is the highest number that you can get when you roll 5 6-sided dice? Each dice has 6 sides, you're rolling 5 of them, and you add the results together. Whatever you roll, you add the total of all 5 dice. What is the maximum that you can get? Well, each dice, the best number that you can roll is a 6, right? So if all of them are 6, then 6 times 5, 6 plus 6 plus 6 plus 6 plus 6, would be 30. So that's the highest total that you can roll. What's the lowest total that you can get? Well, that would be 1 plus 1 plus 1 plus 1 plus 1. That's a 5. Okay? So what you can do right now is go ahead and go to that QR code and click roll, and it will add up, it will roll the dice for you, and it will add up all the numbers. And I just want you to write down those numbers. And an easy way to do that would be to make a 10 by 10 grid, 10 rows, 10 columns on a piece of paper. And then whenever you roll the dice, write down the total that you got until the grid is filled out. And I'll give you an example of that before you start. So this is my roll data. There are 10 columns and 10 rows, and every time I clicked roll the dice, I wrote down the total over here. So the first time I got a 17. The second time I got a 21. The third time I got 17 again. Then I got 19. So I want you to do this 100 times. When you roll 5 6-sided dice, this is called rolling 5 d6. I want you to do that 100 times and record that in a table, or you can even use a spreadsheet like Google Sheets or Excel. And once you're done that, we can continue with this activity. So hopefully you had enough time to complete that experiment yourself. Now let's work on organizing our results into a frequency table. Remember, I mentioned that a frequency table is sort of an intermediary step in between getting our data and turning that into an actual chart. Before we do that, we don't want to make, look at this, look how many columns there will be. Our lowest number is 10, and it looks like the highest is maybe like 26. I don't want to draw 16, 17 columns. Look, 27 even. So instead of drawing that many columns, I might use a histogram, but I definitely want to make sure that I see how often each number got rolled first. So this is what I'm doing. I'm creating what's called a frequency table. So how many times did I roll a 5? Well, I actually don't see any numbers here that are 1 digit. In my experiment, and yours might be different, but in my experiment, I never rolled a 5, a 6, a 7, or an 8, or a 9, even once. So I'll just put zeros there. How many times did I roll a 10? Well, I could look through this entire table to find out where my 10s are. Okay, I got 1 there, 2 there, but I think that would be not the most efficient way to do this. Instead, I will go row by row, one row at a time, and I will just create a tally chart. So let's see here. The first row, I'll just put a bunch of tallies down here. So the first one is 7. In this row, I've got a 17, so I put a mark here for 17. A 21, a mark here for 21. Another 17, so I've got a second notch for 17. 19, okay, I'll put a mark there. 14, I'll put a mark there. 19 again, so there's my second mark for 19. 16, so one mark for 16. 24, one mark for 24. 21, so a second 21. I had another one here, so there's two 21s. And 17 again, so I had 3 17s in total in the first row. Then I'll move on to the second row, and I'll do the same thing. I'll make all of these notches and I'll add onto it. The third row, I'll keep going. The fourth row. And notice that in the fourth row is when I start getting a lot of 19s. And when you start getting a lot of them, I don't want to have to count each of these marks. So after you get 4, the 5th mark, you just put a slash across to show that this is a group of 5. So how many 19s have I got so far? It looks like 5, 6, 7. 7 in total. Let's see, 1, 2, 3, 4, 5, 6, 7. Correct. And I'll keep going like this. I'll do my 5th row, make a tally chart. Now I've got 5 22s. My 6th row, my 7th row, my 8th row, my 9th row, and my 10th row. There we go. Now I have my tally chart fully completed. I've gone through all of my rows and I've made a tally chart. Mine is in different colors so you can see, where each notch is coming from, but yours doesn't have to be in different colors. Yours can be in just the same color. You could just scratch out the number after you make a tally for it, or you could just go through the entire row and not scratch it out, just like I did over here. Once you're done this part, the next part of creating your frequency table is to just write the number down. So I got a 10 2 times. How many times did I get an 11? 5, 6, 7. 7 times. I got a 12, 5 times. I got a 13, 5 times. I got a 14, 5 times. I got a 15, 6 times. I got a 16, 10 times. I got a 17, 10 times as well. I got an 18, 7 times. I got a 19, 11 times. I got a 20, 9 times. How many times did I get a 21? Also 9. A 22, also 9. A 23, just once. A 24, 2 times. I never got a 25. I got a 26 and a 27 once each, and I never got anything higher than a 27. Even though it's possible for me to have rolled a 30, I never got all 6s, even in 100 rolls of this dice. What would be the best graph to represent this data? The best type of graph to represent this data would not be a scatter plot, because we're not comparing 2 variables. We only have 1 variable data. And also, I would not use a bar graph or a pie chart, because we want to see how often our 1 variable occurs. That's true, but we don't want to draw, 100 or 26 different bars. That's a lot of bars for our bar chart. Instead, I'm going to use a histogram, and I'm going to combine a lot of those numbers into groups, into little buckets of numbers, and see how big those buckets are. So a histogram will allow us to create those clusters and then analyze it. While a bar chart and a histogram, so if I wanted you to describe those similarities and differences, while both of them allow us to compare 2 quantities, a histogram would allow us to group that data together in intervals of numbers and then compare those groups, just like this. And remember, this group means all the numbers from 50 to 57. not including 50 because there is a round bracket around that side. Now I'll ask you to complete a histogram of your data. And I'll show you an example of how a histogram is created, and then I'll leave you to create a histogram for your data yourself. Here, I've decided to make 6 buckets. In my first bucket, I'm going to choose the numbers from 1 to 5. In the next bucket, all the numbers that are greater than 5 to 10. Then from 10 to 15, 15 to 20, 20 to 25, and 25 to 30. In this first bucket, from 1 to 5, notice I never rolled a number between 1 and 5. I couldn't have even rolled a number between 1 and 4. That was not possible. But even though it was possible for me to roll a 5, I never did. From 6 to 10, I only rolled two times. Both of them were 10s. From 11 to 15, so this group right here, all the numbers bigger than 10 until 15. If I add these up, in total, I rolled those numbers 28 times. The numbers from 16 to 20, I rolled 47 times. The numbers from 21 to 25, I rolled 21 times. And the numbers from 26 to 30, I only rolled 2 times. I rolled the 26 and I rolled the 27. And now let's make our bar chart. So the highest number we've got is 47, so my bar chart should probably go up to about 50. And now let's make our bar. So this bar will be 0. There's no bar here because I never rolled numbers from 1 to 5. How many times did I roll a number from 5 to 10? 2. So this is how big this bar would be. Very small, just up to 2. This bar, 10 to 15, 28 times. So that's how big that bar would be. It would go to just under 30, about 28. 15 to 20 would be all the way up to here, 47 times. 20 to 25 would be up to here. I rolled those exactly 21 times, just a little bit higher than 20. And all the numbers from 25 to 30, how many times did I roll a number between 25 and 30? Just 2 times, 26 and 27. So that would be my bar there. This is how you create a histogram. So I'll leave you to create a frequency table of your data and then turn that into a histogram.
So hopefully you were able to create a histogram for yourself, and I'll ask you now to answer these questions about your own histogram, and I'll answer them about mine. What do you notice about it, and what conclusions can you draw? Think about that for a minute, and you can pause here if you'd like to take some more time. Looking at mine, I can see a few things that are immediately obvious. That's the tallest bar is the numbers from 15 to 20. The bars beside it are shorter, and the intervals from 5 to 10 and 25 to 30 are very, very short. So that probably means that when I roll 5d6, 5 6-sided dice, I'll probably get a number between 10 and 25, especially those between 15 and 20. This sort of distribution, the way the data is spread out, is called a normal or a Gaussian distribution. It means that all the numbers are centered around the mean, which in this case would be about 17.5. And so they're about evenly spread out to the left and right. It's not perfect because this was experimental probability, not theoretical, but this is what we would call a normal or Gaussian distribution. There is another word for it that you may be familiar with, and that is called a bell curve. This is shaped like a bell, just like that. And it's for that reason that we call it a bell curve. So what did we learn in this lesson? Well, we learned that one variable data can come in 3 types: categorical, discrete, and continuous. We also learned that we could choose a chart that fits a certain data type better than it would fit other data types. We learned certainly that pie graphs and bar graphs would be great for categorical data. Bar graphs would also work for discrete data, but for continuous data, we probably need a histogram. Once our graph is complete, we could check its distribution, if it's a histogram or if it's a column chart, to maybe draw some more conclusions about that. The first kind of distribution, and this is the one that I noticed my graph has, is called a normal distribution. But there's also a skewed and a bimodal distribution. And this is sort of what they look like. So a normal distribution is symmetric around the mean. So if this was my graph, if this was a curve, like if all the columns sort of ended up looking sort of like this, where they were like really high in the middle, and then as you got further towards the edge, they got lower really quickly, we would say that is a normal distribution. It's symmetric around the center. A skewed distribution looks kind of similar, but the data values actually trail off more sharply on one side than on the other. So it might look something like this. It's almost like a bell that has gone wonky, right? One side of it has sort of melted and the other side is still standing strong. So this is what a skewed distribution looks like. You would only use this for if you have lots of values down here, of ordered values, and then you would see like, oh, if there's a lot of bars over here that are really tall, that means that these values will occur more often. Lower values occur more often. And if it's skewed to the right, that means that higher values occur more often. Finally, there's something called a bimodal distribution, and that's characterized by two distinct peaks. So usually what this would mean is that, yes, either these numbers will pop up pretty often, and these also pop up pretty often. So if you were to pick a random subject from your data set, you might find out that they would respond in a way that would lead them either in this direction or in this direction, but not a whole lot of people seem to be wanting the middle. And there you have it. You can actually use spreadsheet software, such as Google Sheets, to create tablets and charts like this with a lot less difficulty. Let's actually see Google Sheets opened on a phone or computer, and let's see this in action. So one way to do that is you can either go to sheets.google.com and you can press that plus sign to open and start a new blank sheet, or you could just scan this QR code. That should take you to the very same place. Now, when you do that, if you use the QR code, you'll see something like this. And if you used the link itself to start a new sheet, this would be blank, and you may need to fill it out with roll number 1, roll number 2, roll number 3, and then what was your total out of the 5 dice for that row. Once we have all of that data filled out, I'm going to start filling out this data over here. And this data is, notice that I've got something called a formula inside this rectangle. In Microsoft Excel or Google Sheets, there are columns and there are rows. So the words roll number, that's right now in cell 1A. A cell is a rectangle. How did I know it was, or cell A1? So that's because the column has an A in it and the row has a 1 in it. Okay? So what is this? What am I trying to do here when I'm putting this formula? This is the formula COUNTIF. What does it do? It returns a conditional count across a range. So what is the range that I'm looking to count up certain things? I'm looking for column B, and that would be B colon B. Then I put a comma, so look, this is what the formula is saying to do. Type in COUNTIF and then a bracket, then type in your range and put a comma, and then put in the criterion. So the range is the range that is tested against the criterion is here, right? It's all of column B. And the criterion is actually the pattern or the test to check to see how many of those appear here. So over here I've put COUNTIF range B to B, so it's going to count all the items in this range, and it's going to give us a criteria. It's going to tell me how many there are. It's going to count them if they meet this criterion, which is equals to D3. This is cell D3 here in purple, my friends. So if there are any ones, this formula will count them and it will just give you the final answer here. And I'll keep doing this for the whole row. I can copy this cell and I can paste it down all of these rows right here, and the formula will move over automatically. This is what it looks like when I have filled out my table. So I've rolled the dice 100 times. I filled out my frequency table with this formula. I've copied the formula and I've pasted in all of these. And notice which ones have popped up more often. It looks like 16, 17, and 19 have popped up really often. 11 and 7 has popped up as well. I've rolled an 18 also 7 times. So this is a frequency table, and this is the exact same frequency table I did with my tally chart earlier, except I didn't have to work nearly as hard to make this. I just used this formula. So what can I do with this? Well, if I select my frequency table and then I press, insert chart, you'll see that it will automatically choose a chart for me, and it has chosen a column chart. And here you can see that there are in fact 30 different columns, and we can see how many times each number got rolled in a nice chart. We can see, wow, the chart is really high in the center and falls off towards the end. But remember, we want to create a histogram. So I will delete this, and the way you create a histogram on Google Sheets is you don't even need the frequency table. You just need to select this column right here, column B. Once I've selected that table, again, I'm going to go to Insert Chart, and this time I will select the chart type. I'll click on this menu, and I'll make sure that I have selected histogram of roll total. So again, once again, I select this column, I click Insert Chart, and it gives me a few options. I'm going to click the arrow, and I'm going to make sure I click a histogram. Once I do that, I can go over to Customize, and I can make sure that my bucket size is not too big. Remember, I wanted a bucket size of just 5, and I've done so now. And now take a look at my beautiful histogram that I didn't have to do any work to complete. All I did was I selected this column, and then I clicked Insert Chart and chose a histogram. And with the customizing the histogram, I made sure that the bucket size was 5 units.
If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.